So now, for example 4, it says an engineer is asked to design an archway into a new school building with this equation. Now this equation is interesting because if you think about this, I could rearrange this equation to be H is equal to, we could write that as H is equal to 16 minus D squared. Don't be afraid to rearrange your equations, because isn't this a perfect square? The square root of 16 is 4, and the square root of D squared is just D, right? So this is going to give us a difference of squares. So now, the big hint, when they go and ask you, hey man, how wide and tall is the arch? Well, we can figure out how wide this arch is by using the difference of squares to find the x-intercepts. So our original equation can be rewritten as H is equal to 16 minus D squared. When you factor that, you end up with, well, 4 minus D and 4 plus D. Now let's go back to the problem and identify some stuff that might give you guys some issues. So, the engineer is asked to design an archway into a new school building based on this equation, where H is the height in meters and the arch is the horizontal distance in the meters from the center. Now, because that's from the center, this gives us a hint. When we're talking about the hint, this might mean the AOS, the axis of symmetry of the parabola that this equation represents. So when we have this parabola, it says, how wide and tall is the arch? Well, if I end up with H is equal to this, so now what I could do is I could literally set that equal to 0 to find how wide it is by actually solving for D. In this case, my D intercepts are, well, 4 minus D is equal to 0, and the other one is 4 plus D is equal to 0. Solving for D, D is negative 4 on this one, and D is 4 on this one when you solve. Now, based on that, if we wanted to calculate our axis of symmetry for this, we're going to end up with, well, notice it's no longer x, it's D equals, and then we have 4 plus negative 4, and then we're going to divide that by 2, and that ends up being our D is equal to 0. Now, don't we normally take our axis of symmetry and substitute and back substitute into our original? Let's call this equation number 1 up here. So we're going to back substitute into it. So we're going to sub D equals 0 into 1, into equation number 1 there. All right, into 1. By doing so, we end up with H is equal to 16 minus 0 squared. Uh-oh, the H value is 16. So, based on all that information that we just calculated, we have the following information. Now, we said if we want to find the distance between D is 4 and negative 4, that distance, that horizontal distance, is going to be 8 meters. and the height based on our maximal y value calculation, i.e. taking our axis of symmetry and plugging back into our equation to find either the max or the min. And the height, the height maxed is 16 when d is equal to 0. And that's all she wrote, guys. That's it. So now, if you think about it, when we take a look at part B of our problem here, so that's this thing right here, you want to think of what's happening here. Based on our information, if we took a look at what our graph looks like based on all the calculations we did in part A, our graph is literally going to look something like this. Here's our x-axis, and then what we have is an arch that is centered about the x-axis, where our distance along the ground is -4 for our first intercept, and our second intercept is at 4. And that's how we ended up with a distance of 8 meters between those 2 points. And then our maximal value ends up at 16 on the h-axis. Okay? So, when we're talking about the arch, if I wanted to know what values d could take, the only values that d could take are literally in between -4 and +4, because any other points past that mean nothing to us, because we know that this part here, from here on, is the ground of our arch. Okay? That's it. So, in this case, we're going to say d is greater than or equal to -4 and less than. D is less than or equal to 4. So, we're essentially saying that our answer is literally between these two values, between d is -4 and being less than or equal to d to the 4, d equaling 4. Now, for part C, what I'd like you to do is I'd like you to find a way to use this picture of our arch. Again, this picture of our arch with it being split down the middle. Remember, this is -4 and this is +4. So I guess this is 4, 0, and then this is -4, 0, and this point here up at the top is 0, 16. I want you to try and answer this question on your own. This is a special question that we'll try to look at later. If you're in class, we'll go over this. If you're not in class, you need to come and see me about this problem. All right. Now, I will not put this up online as a solution for part C. Your job is to work through it and see if you can come up with some way to fit a door or a number of doors that are 2.5 meters wide. When I want you to do this, I want you to consider the height of the door as well. So I want you to consider the height of the door as well. Height of door as well. Now, you guys are enriched. Take your time and work through this problem. And then we'll take it up together as a class. We'll have interesting discussions about it. Now, what I want you to do is I want you to do these specific questions. Okay? And I want you to do at least one of these. At least one. Do at least one of those questions. At least one of the extra challenge problems.